This video is going to cover both examples 5.5.3 and 5.5.4. They're from the section in the notes on differentiation and integration of vectors. Both these examples are on integration. The previous two examples were both on differentiation. So find the integrals with respect to time, or t for time, of the following two vectors. Like we did with differentiation, we can just do this term by term. So for part A, integrate 2t and we get t squared. Very importantly, we need a constant. And there's going to be quite a few constants here, so I'm going to call it C1. Very, very important. You must not forget that. Integrate the j component, 4 sine t, and you get minus 4 cos t. Again, we need another constant. Don't use the same name. Make sure they have different names. I've gone with C1 and C2. Those are the separate parts. Now put them together. The separate components. Let's put them together now. The integral of 2ti plus 4 sine t j with respect to time, that's what dt means, is t squared plus c1 by I, so we need these brackets, plus minus 4 cos t plus c2 all times by j. Now you could leave your answer like that, there's nothing wrong with that, or if you wanted to, you could expand the brackets and write it like this. So notice I've put c1i plus c2j at the end. It's up to you which version you use. I'm going to use this one more in subsequent videos. So part B, same process. Integrate each component separately, put it all together at the end. So integrate the I component. It's a good idea once you've done all these integrals to check they are correct by quickly differentiating them, ideally in your head. Or if you need to write it down on paper, then go ahead and do that. The middle component is an invisible 1. Integrate 1 with respect to time and you get t. Remember our constant every single time. So this is a new C1. It's not the same C1 as part A. So I could have called it C3 and then C4 if I wanted to. And the K component, we get T cubed, another constant, put it all together. So this is the I component, that's the J component, that's the K component. There's nothing wrong with leaving it like this. But again, if you want to, you can expand your brackets. Example 5.5.4, given that A is a constant vector, find the integral with respect to time of the following two terms. So A could be something like I minus j plus 6k. That is a constant vector. There's no variables involved here. That's just one example of what it could be. So we're integrating with respect to time. As part A, the integral of A, it's not just going to be at, we're going to need a constant there as well. Now the constant is not just going to be C1. When you have an equation, you cannot add together vectors and scalars. So for example, something like 3i, where I is a vector, plus 7, we simply can't do that. 3i is a vector, 7, or any number on its own, is a scalar. We can't go adding them together. So it's no good writing the vector a times t plus a constant. It needs to be a vector term. If we were to just consider the component of a, or the coefficient rather, it's an invisible 1, and integrate 1 with respect to time, you get t plus a constant, which I'm calling c1 to be consistent, and then bring the a back in. That is another way you can approach it if you want to. Part B, similar situation. If you want to just focus on the coefficient, then the integral of 3t squared is t cubed, very importantly, plus a constant. And then for your answer, put that in front of whatever vector it came from. So 2 ways of giving you answers, both the same. And that concludes example 5.5.4.